Welcome everyone, and thank you for joining us today for the webinar by Q Infotech on IoT Security. Are we 2020 ready? I'm Vasundhara, AVP Marketing, and your moderator for today's session. Little housekeeping guidelines before we get started. All participants are on mute by default. In case of any questions, kindly type them into the question box in your control panel. Today's topic will be covered by Akshay Agarwal and Mohit Sharma. Akshay heads the information security vertical at Q Infotech and has authored many white papers and articles, is an ardent speaker at tech forums, and loves to develop tools in his free time. Mohit is a senior lead and a pillar of the information security team and one of our best SMEs around. Both Akshay and Mohit have an experience in web, mobile, network, and thick line applications and red team assessments. Let's now quickly get started with the webinar. Over to you, Akshay.
Thanks for the lovely introduction, Vasundhara. Hello. Thanks for the lovely introduction, Vasundhara. Hello, everyone. I am Akshay Agarwal, and along with me today in this webinar is my friend and colleague, Mohit Sharma. Together, we are going to be covering this topic of IoT security, and we'll try to understand with some live practical demonstrations how ready we are to face the challenges that lie ahead of us in the IoT security space. Now, imagine you just bought yourself a new smart car. You take it out for a spin, you're riding it at a high speed along the highway, and suddenly you realize that you're unable to engage the brakes. The gearbox is jammed. The car is starting to accelerate, deaccelerate on its own accord. You can no longer control the wheel box. Just imagine how life-threatening it can be. And just when we start to think that something like this can only exist in the typical sci-fi movies or our Hollywood blockbusters, it apparently became reality when two security researchers named Miller and Wallace hacked into a Jeep car. They took complete control of it, and all this was done remotely with the help of internet. Now, the only problem that I see here is that the car was a smart car, and we must not forget, if it's smart, it is vulnerable. So here's a smartphone, a vulnerable phone. Here's a smartwatch, a vulnerable watch. Smart car, smart city, and the list is just endless. I hope you get my point. As the Internet of Things continue to grow, so do the security and privacy risks and vulnerabilities associated with IoT devices on enterprise network. And this is exactly what we intend on covering today. The current state of IoT security, the IoT attack surface, as organizations worldwide are looking to assess and manage the risks, implement basic cyber hygiene, and improve their security posture. Some de facto standards and methodologies which come in handy along the way. And we are going to support all this with live demos that we have prepared after working on live IoT systems to help you better understand where we stand today in terms of IoT security. And with this webinar, we will also aim to discover some of the best strategies for achieving security at every level in IoT. Now, when it comes to IoT, the first thing that comes to my mind is botnets. The detection of IoT botnets is at an all-time high, and the number of varieties is also steadily rising. How can I forget the Mirai botnet attack? This hack, although took place in October of 2016, still ranks as the largest DDoS attack ever launched. The attack that targeted a DNS service provider named DYN. It used a botnet of IoT devices. The impact was so much that even the media titans like Twitter, Reddit, CNN, and even Netflix were badly affected. It was very interesting. The botnet is named after Mirai malware. Once it successfully infected a vulnerable IoT gadget, it automatically searched the internet for other vulnerable devices whenever it found one. The malware used the default name and password to log in into the device, install itself, and repeat the process. Well, I find it quite damaging. There's another example of baby monitors, which is there in every IoT hacker's handbook. Baby monitor, which started as a one-way radio transmitters, have evolved into sophisticated Wi-Fi enabled smart devices that now have a receiver, video camera, infrared vision, and God knows what. These same high-tech capabilities have turned this into a true nightmare, making it susceptible to hacks virtually from anywhere in the world via their Wi-Fi connections. According to Symantec, 90% of the IoT attack targets the router and the network cameras. According to a latest survey put forward by our friends at Gartner, the enterprise and automotive Internet of Things market will grow to 5.8 billion endpoints in 2020, a massive 21% increase from 2019. And by the end of 2019, 4.8 billion endpoints are expected to be in use. There's another survey by F-Secure. As you can see, they have their global honeypots across the world. In 2017, their honeypots received around 246,000 million attacks on their global honeypots. This number grew exponentially to 2.9 billion in just the first half of 2019. Just now, if I wanted to go and check for, let's say, smart cameras or smart refrigerators, I would just go to shodan.io. Now, for the uninitiated, Shodan is the world's first search engine for internet connected devices. And I could just type and see how many smart devices are online right now. Smart cameras, routers, or IoT devices, or smart anything. Any device that is visible on the open internet can be targeted by a botnet. And if it has a vulnerability, it can be hacked within minutes. As you can see in this video here, there are around 6,887 devices, live IoT devices online right now, and it gives me a list of IPs that I can play with. The idea that we are becoming a completely connected culture is no longer a nuance, it is status quo. The pervasive connectivity is changing the face of the whole industry, whether in healthcare, agriculture, automobiles, our home, offices, it does not matter. Bringing millions of endpoints and vast amount of the digital infrastructure that did not even exist prior to this type of evolution, and despite the rush to create more IoT appliances, most manufacturers are not outfitting these devices with proper security, if any. Video cameras, for example, which were intended to improve security, are getting hacked. Some industries even tend to underreport attacks, which is so sad, making it difficult to gauge the true risk of software breaches. And this practice is more prevalent in the industrial and retail sectors. Power grids is another example, which is not just vulnerable to software attacks, but software bugs that can actually cripple the infrastructure. Now let's take a look at IBM model of Internet of Things. It includes all the components that enable businesses, governments, and consumers to connect to their IoT devices. The IoT system includes remotes, dashboards, networks, gateway analytics, data storage, and also security. This model represents how the IoT architecture looks like when divided in different layers. So the first layer is the user itself, which has the controlling device. So this could be either the hub device or the mobile application, which is then connected to the cloud where all the user data is getting stored. And then comes the radio communication. This is more of a human view of Internet of Things. For data-driven applications that involve edge analytics, a basic three-tiered architecture captures the flow of information from devices to edge services and then the cloud services. Now let's quickly take a look at different components that need to be secured in a typical IoT ecosystem, or in other words, the different components that can be hacked at each layer. We are going to demonstrate shortly various kinds of attacks that can be unleashed on these different components, be it firmware, hardware, or something as common as a web or mobile application. Firmware, hardware, and connectivity protocol vulnerabilities are used to hijack devices and their functionality that are discovered on a daily basis. As when it comes to Internet of Things, product vendors are yet to fully introduce security at the heart of development. The job of a security researcher is basically to cover all bases so that what gets released is a secure and safe product. And in order to do so, you need to comply to certain guidelines, methodologies, or even a checklist to make sure that all endpoints are correctly tested and comprehensively. And what better in terms of checklist than OWASP, which stands for Open Web Application Security Project, the de facto standard. Just like we have been using OWASP Top 10 for web and mobile applications, we have a similar OWASP Top 10 for IoT. Now, I'm not saying that this list is completely evolved, but it does serve as a great reference point when it comes to executing security tests on IoT products. Vulnerabilities like use of weak or guessable or hard-coded passwords, or unneeded or insecure network services running on the device, the lack of ability to securely update the device, use of deprecated or insecure software components or libraries, insecure interfaces in the ecosystem outside of the device that allows compromise of the device or its related components. And yes, not to forget, lack of physical hardening measure, allowing potential attackers to gain sensitive information that can help in a future remote attack or even take complete control of the device. A security researcher must validate all this and more. Now that we have good understanding of the different attack vector, let's take a look at the step-by-step process and the methodology unfolding these various attacks. I will explain the methodology, after which Mohit will show you some demos of these very attacks on the components that we have just learned about. This methodology here actually takes cue from the last slide where we saw all the components that need to be secured. So we start off with attack surface mapping, first step in the ladder. In this phase, we discuss the architecture of IoT device, and once we have the architecture diagram in place, can we then identify the components involved, understand the communication medium between each of these components, and also figure out what can go wrong with each component. We must also figure out the second phase here talks about firmware reverse engineering and binary exploitation. Here, with the help of reverse engineering, we identify the file system processor types, extract these file systems, then search for hidden secret keys, username, password, the juicy information, API keys, binary files using various binary exploitation techniques that Mohit is about to cover. In the third phase, that is hardware-based exploitation, we assess hardware communication protocols such as UART, SPI, I2C, JTAG debugging, and their exploitation, the logic sniffing, bus tampering attacks, protection mechanism tampering. Now, next comes the web, mobile, and cloud vulnerabilities. So your typical web dashboard vulnerabilities like cross-site scripting, injection-based attacks, insecure direct object reference attacks, the authorization and authentication bugs, and more. The mobile app security issues will apply equally here, such as the identification and exploitation for Android and iOS platform-based issues. The API-based security risks are also assessed along with cloud-based vulnerabilities in the backend system. Next comes the radio security analysis. Here, the assessment of radio communication protocols and the reversing or proprietary protocols is done. We will also try to access the encryption key through various techniques. We will learn the exploit communication, the protocols such as BLE, ZigBee, LoRa, and all this is learned through insecurities and the vulnerable implementations. The next is the PII analysis, which although it is optional, and I don't even think I need to stress the importance of PII in 2019 and ensuring that no PII information is being leaked through any channel, be it web, mobile, hardware, or even radio. And we end it all with a detailed comprehensive report, which we do in any typical given security assessment. Now with this, I'll let Mohit take us through these concepts with the help of some live demos. Over to you, Mohit.
Thank you, Akshay, for sharing stats and insights about the recent breaches and how the increased number of IoT devices making us to rethink whether the smartness and ease of access to everything is really worth it to lose such data and privacy. But it did not mean we should stop using the IoT device and move back to the traditional approach. Instead, we should become smart enough to trust the right vendor and the right product. So today we will discuss few examples along with demo to analyze the products of few vendors, whether they are right from the security perspective. Let's have a look at the tools that we are going to use to analyze the product or firmware of different layer of IoT devices or to exploit them. So first we will start with binwalk, which we are using to analyze and extracting the firmware or dump the entire file system of a firmware. Then there is firmwalker, which is an automated script to look for security issues in firmware. Then burp suite, which is a proxy tool. We are using it to intercept the HTTP traffic and manipulation. Then ZX, and mobile application decompiler to reverse engineer the mobile application and to see for the hard coded information in it. Then there is Firmadyne, which is one of my favorite, and we are using it to emulate a firmware. I find it so interesting that we can emulate a firmware and check the functionalities it offers. Then Atify OS. This one is a complete operating system, consists of almost every tool that you can see on this slide and much more than that. It is similarly like Kali Linux for web application pen testing and network assessment. Then there is bind shell, which we are using to embed a backdoor in the firmware, which is created by Osanda Malik, a great security researcher. Then last but not least, firmware mod kit. Firmware mod kit used to extract and rebuild the malicious version of the firmware. So I hope everyone must I believe that everyone must interact with the router on their daily basis to search the internet, to check whether the internet is working or not. But have you ever analyzed whether that router is sending your data to somebody? So, and also, as Akshay said, that 90% of the IoT attacks targets the routers and network cameras. So for the first phase, we are taking an example of D-Link router firmware. Now the question arises, why firmware? What could go wrong with the firmware, or what would an adversary achieve through a firmware? You will be surprised to know what all mistakes manufacturers do while manufacturing the device, what they left for hackers to play with. So let's analyze a firmware and see what could go wrong with the firmware. As you can see on your screen, I have attached a screenshot of a D-Link firmware. If you want to check what is your version of your firmware, you can simply go to Tools, Firmware, and see the version. For analyzing the firmware, there are 4-step process. First is get the firmware. I might sound silly, but yeah, you must be thinking that how to download the firmware. This should be an easy process that I can go to the vendor website and download the firmware. But there are more ways to it. And as Akshay mentioned, IoT contained more components like mobile applications, web interfaces, and radio security layer. So sometimes what manufacturers or vendors did, they embed the path of the firmware in the mobile application. So to get the firmware, you need to reverse engineer the application and look into the source code of the application. And the third way to download the firmware is to sniff the update mechanism, as vendors push update regularly within a time span of 3 to 6 months. Then you can sniff those updates with the tools like Wireshark and Burpsuit and check on which server they are making a request, and then you can download the firmware from there. Then the last way to download a firmware is to dump it from the flash chip. You can do it by various hacking toolkits, and we will talk about them in the upcoming slide. So we have discussed the phase to how to get the firmware. Now the second step of the firmware analysis is to extract the firmware. In firmware extraction, we identify the file system, architecture on which it is running, and then dump the entire file system. The third step is to try to emulate the firmware. We look for the binaries in the firmware after getting the firmware extraction. Then we try to emulate those binaries to check what all functionalities it's offer. Then the last step is to attach that binary to a debugger and to set a breakpoint or to pass the argument or to try to control the execution of the flow and to check for the vulnerabilities like buffer overflow. So in the previous slide, we discussed about the file system types, the different file system types, and what all file systems firmware has. So here is a list: Squash FS, CRAM FS, JFSS2, YEFS2, and EXT2. These are the different file system these firmwares have. The architecture they mostly contain like MIPS, Little Endian, Big Endian, then ARM. Now we know what are all file system in a firmware, but how to identify a file system if we have a firmware with us? So we can use tool like binwalk and then type in a command like binwalk space the firmware name. Now you can see in the screenshot that it shows us what is the file system this firmware has, what is the processor architecture, and what is the bootloader. Now we know we have identified the file system. Now the next step is to dump the entire file system. So what are the tools that we require to dump the file system? So these are the tools like unsquash fs, binwalk for squash fs, uncram fs, binwalk for cram fs, unjfss2 for jfss2, unyefs2 for yefs2, and so on. So now we have extracted the firmware and we have identified the file system. Now what to look for in that particular file system? So our goal is to look for configuration files, other binary files, hidden secrets keys like admin, password, remote keys, API keys, backdoor, and so on, and URLs, vulnerabilities in common binaries. These firmware mostly contain binaries like SSH, ping, TFTP. We can look out for vulnerabilities in them. Then URLs, third-party URLs, script files, email addresses, and IP addresses, and the common web server information. But the worst case scenario or the worst thing that one can do with the firmware, they can backdoor a firmware to create botnets or to spread malwares. So let's quickly see a demo that how all this could be done. So I have downloaded a firmware of D-Link firmware.bin, and one thing I forgot to tell you guys that the firmware have extensions like .bin, .img, .pkg, so you can identify those using those extensions. So now I simply launch binwalk to identify the file system. So file system is squash fs, processor architecture is MIPS, and the bootloader is UI. Now we'll try to extract the firmware, which we can do using command like binwalk -e and the path of the firmware or the name of the firmware -e to extract the firmware. So we did that. Now it will create a folder for us which contains all the files that firmware file system has. So we'll simply go to this directory. So this is the file system a firmware can have. So the bin directory contains binaries. The sbin directory contains also binaries, and etc contains some sensitive files called password and so on. So now my target is to look for the informations like telnet credential, SSH credentials. So I will simply use the utility called grep, then -irn and the keyword telnet. So it will simply search telnet in these directories and it will list out all the files that contains keyword telnet. So it took 40 to 50 seconds. So these are the files that contain telnet keywords in it: etc script system.sh and telnet-d.sh. So we'll simply go to this path and try opening these files. So as you can see in this file, we are having a username -u alpha networks colon the password, but the password stored in a variable called image_sign, and we can see the value of image_sign stored in this file, and we can simply go to this directory and open this file and check what we found. So now this is the telnet password. So we can now log in using telnet port with the username we found alpha networks and this password. So this is the manual way to look out for the issues. There is an automated script and we can save our time to analyze a firmware using firmwalker.sh. So we'll try the same thing using firmwalker.sh. Firmwalker is code in such a way that it contains keyword and it look for those keywords like admin, backdoor, API key, secret key in the file system, and it will list out all the files that contain those keywords. And it will store all the information in this file firmwalker.txt. So here I invoke the script with the path of the firmware. Now it will look for bin files, patterns, upgrade, root, admin, these keywords in the following files, and the password pwd drop bear ssl. So it will look for those keywords in those files and store all the information in firmwalker.txt file. Now I'll simply open this file and grab so I'll try to fetch the similar file which we found using the manual approach or the grep. So it will list out the same file which contains the credentials. But some of you must be wondering that this should not happen in 2019. Now companies and developers or vendors are smart enough to tackle these issues. So here is an eye opener for you. CVE Details is a website that contains already reported vulnerabilities, and any security researcher can go to this platform and report the vulnerabilities. So they assign they assign a code to a particular vulnerability in the pattern you can see on the screen, CVE 2019-6005, in which CVE stands for Common Vulnerability Exposure. 209 is the year in which it is reported. So I simply go to this website, search for smart firmware CVE 2019. So as you can see on your screen, already 1,000 vulnerabilities has been reported to the firmware, related to the firmwares till date, and it's still the November month in the 2019. So we have seen one use case of what could go wrong with the firmware, and that results in hacker getting the access of telnet credentials. Now let's discuss the worst case scenario. What if someone using your router to scan other devices or using it to create a botnet? As Akshay discussed about the Mirai botnet, here is an alternative of Mirai botnet, which Fortinet team found a few months back. So initially the Mirai botnet was used to perform DDoS attacks on a particular target, but the hackers alternate the code or try changing the code in such a way that they can use it for the crypto mining or making a money out of that botnet. So what it does, a hacker controls a control and command server. It simply sends the malicious command to infected devices and then fetch the response from those devices. And these infected devices regularly scan the vulnerable IoT devices, which contains default credentials, open ports, and if they found any vulnerable device, they make it a part of it and convert it into a proxy server. And then they can sniff all the data. They can sniff all of your data and get the information out of it, and also use your device for the crypto minings for the cryptocurrencies like bitcoins, ripples, ethereum, etc. And there are few botnets, there are other few botnets which were introduced in 2016, which is Linux IRC Telnet. It targets routers, DVRs, IP cameras, and it supports both IPv4 and IPv6. And there is Bashlight found in 2015, infected over 1 lakh devices. And Mirai we have already discussed. But there is the other side of it. There are some botnets created by vigilante hackers like Linux.Wi-Fi Watch, which simply go to any IoT device and log into their telnet session, which have default credentials, and simply close the session of that that IoT device and instruct the user to log in again, and to update the firmware. Similarly, breaker bot, if it was unable to secure the IoT device, it simply breaks the device, and so goes for the HASM. So now we know that what could go wrong with the firmware and what an adversary can do with the firmware. So let's quickly discuss the worst case scenario. Firmware backdoor. How to create a firmware backdoor. So the firmware backdoor process is a 8-step process. First step is to extract the firmware, which we have discussed in the previous slide. Then the second step, to identify shell files triggered on the boot time. The third step is to embed shell path on identified shell file. Then we will create a bind shell according to the MIPS architecture. Then we will simply put that bind shell on the embedded path, which we discussed in the second step. Build a new firmware using firmware mod kit. Then try to emulate the firmware and connect to that bind shell port via NC. Now let's see all of this thing in a practical demonstration. So we have taken an example of D-Link router firmware. So the first step is to extract the firmware, which we have already seen, but we are not using binwalk to extract the firmware in this demo. We are using firmware mod kit, in which we have a script called extract firmware.sh to extract the firmware. Now we have extracted the firmware. I will go to this directory and try identifying files which triggered at the boot time. So those files stored in directory which is called initd. Now we'll move to that directory and check what all file it contains. So these are basically symlinks. Symlinks to these files contain these files stored in different directory. So we'll open one of this file, system.sh, and the third step is to embed the path of the shell file. So we'll go to the directory system.sh etc script, and now we'll open the system.sh file. So we have already embedded the path etc/template/bind shell, and we have echoed backdoor starting. Now I'll create a bind shell and put that bind shell into the same path etc/template. As you can see in the screen, the third step is to embedding the shell path. Now I'll create the shell file. We are using a bind shell created by Osanda Malith, and now I'll try to compile this file according to the MIPS architecture. Because these files you cannot directly compile using x86 architecture or normal or Windows or Linux based system or x32-bit or x64-bit architecture. So we need cross compilers for that. So I'm using MIPSEL. You can use GDB multi-architecture debugger for that. So as you can see, I've invoked this GCC bind. I have given the name of my file -static-o, and then the name I want to give that file, which is bind shell. So you can see it created a file called bind shell in this directory. Now we have identified the shell file. We have created our bind shell. Now the next step is to put this bind shell onto the embedded path, which is etc/template. So now I have copied sudo cp the bind shell into the present working directory, which is etc/template. Now we have completed few steps. The next step is to build a firmware which have our backdoor firmware, which have our backdoor bind shell in it. So I'll try to create a firmware. So for that I'm using build firmware.sh. I'll invoke it with the firmware name, the folder firmware, the extracted folder name -notepad-min, it will simply create a new firmware with us, which has our backdoor in it. As soon as a device get boots up, and it will automatically triggered, our bind shell will automatically get triggered and give us the shell access. So it will create a firmware, new firmware.bin. Now the next step is to emulate this firmware, or to provide a interface to this firmware. So for that I'm using Firmware. So you can simply invoke :fat.py. It will ask for the firmware name, then the brand of the firmware, and it will simply ask for 4 times for password, which is same as Firmware. So now it will create an interface for us and allocate a IP to it, which is 192.168.0.1. Now I'll try open this URL or this interface in my browser, and as soon as I hit this IP in my browser, I'll get a shell. So I have also enabled connection to with NC, the IP of the interface, and the port, which I mentioned in the bind shell 9999. So as soon as I hit the IP, I'll get the shell. It will prompt me the shell, and after getting shell, I can execute any command in it, whether it's ls, pwd, or any command that a super user or as a user you can run on your device. So basically, I can control your device, I can kick you out, or I can lock your router. So as you can see, I got the shell. Welcome to Sandamalit bind shell. Now I can run ls here, and then cat CPU info to check what architecture it is running on, processor type, and other information. So now we have discussed the firmware layer. Now let's move to the. I hope now we all have some understanding of what could go wrong with the firmware and what damage it can make on our daily lives. But that's not it. As we promised that we'll cover others layer as well. So let's discuss the another layer, which is web and cloud interface. But okay, numerous gadgets and devices have built-in browser web servers that host a web application for managing them like any web server or application. But there might be flaws in source code that cause the interface to vulnerable to web-based attacks like SQL injection, XSS, command injection. So let's see a demo of web interface having command injection vulnerability in it. But before that, let's quickly discuss what command injection is, how severe impact it has, and what kind of privileges an attacker can get if a system or web interface is vulnerable to command injection. So I have taken an example of a PHP application. This application has a backend code, and it's taking a file name of a file and removing that file from the system. But that get variable is taking input parameter as file name, passing that variable to system command, and there is no sanitization on the input. So what a malicious user can do, it will simply provide the file name and the instruction, and also add malicious command to it to check how the server responds, or whether the server allows to execute the command at the backend. So in this scenario, malicious user provided ID, and the application respond with for the file name, but along with that you can see it will show me the results of the ID command, the user informations, the group information. So let's quickly discuss a demo which we found, security researcher found in a Netgear router firmware and see how we can exploit the command injection vulnerability. So this is the detail. This vulnerability was found by Chen, and this vulnerability was found in Netgear router firmware. So these are the listed products that all are vulnerable. WG102. We are taking an example of WDNAP 360, and this vulnerability lies in the files that are available in the firmware file system. These are the files: board data www.php, board data na.php. So I'll simply download the firmware and check the file system for these files and try to exploit it. So this is the firmware. This is the image I have extracted using tar utility. Then first I'll check the file system. File system is squash.fs. Now I'll try to extract it using binwork-e. I will simply go to this folder and look for the file that we discussed, board www data, and try to locate that file. This is the file system. This is the file name, board data www.php. I'll try to locate it. And see where it lies. So this file lies at this path. Now open this file to analyze what is wrong with this file and why it let us to execute the command injection. So this is the file. Here you can see in the code, the request variable contains 3 input parameters: write data, MAC address, and reg info. And this MAC address is passing to the function called exec. It is similarly like system function. They basically runs OS commands on your backend server if the input is not sanitized, and user can input anything, whatever he wants. So now I'll try to emulate this firmware using Firmware, the same tool which we have discussed in our previous demo. So I'll try to, I've given the path of the firmware, the brand name Netgear. Now it will ask for password for a few times. Now wait for the interface. Now the Firmware 9 gives us the interface, this 192.168.0.100. I'll copy it, paste in my browser, and you can see I'm getting the screen of the Netgear or the web interface for the Netgear. But we remember that vulnerability lies in board data www.php file. So try accessing it. Now, as you can see, we didn't require any authentication to access this file, but we need to input something here, and this file contains a input validation of 12 characters or 12 numeric characters minimum. So I'll try entering those values and capture this request using burp suit. Send this request to repeater, and now I'll fiddle with this parameter. But here the scenario is different from command injection. This is blind command injection. But in blind command injection, you don't see the exact response. Like if I'll run ls command here, I'll not the server will not let me see the file system here. It will give me the hint that command is executed at the backend system. Like it will give me the hint like update success, command get executed successfully. So let's see that. So I try entering ls with -c0 and end the instruction to start again the instruction, and you can see in the response I got update success. So now I know that application is vulnerable to command injection. So what I can try is to access the etc password file. Everybody must be aware about the etc password file in Linux, how sensitive it is. So I'll try to copy the content of that file and try creating a file and then try accessing that file. Try accessing the same file. So I'm using copy etc password and copying the content of etc password in the password file. So I hit go. Let's check whether the server, yes, the server gave us the hint, update success. Now I'll simply go to browser hit /password and capture the request using burp suite proxy and see the response, whether I am able to see the content of, yes, here you can see we are able to see the content of etc password file. So, and these are the some of the examples of recent IoT vulnerabilities which were reported in 2018 and 19. And some of you can see that here are most of the vendors are popular, like Sony Bravia Smart TV was vulnerable to DOS. LG Smart Network cameras were found to be vulnerable to broken access control vulnerability, in which an ID is passing into the URL, and you can simply change the ID and check or stream the videos of other users. Then there is CSRF in another TV vendor and authentication bypass in smart home. Now we have unfolded security on two layers. Now let's talk about the third layer, which is mobile application, which is most common, mostly used in almost each and every IoT device architecture, whether it is a smart bulb, smart plug, kettle, refrigerator. So for this phase, let's consider a mobile application of a smart plug and see what could go wrong with it. So this is a smart plug which is provided by Kankan, a Chinese vendor, and it is already listed on Amazon. So let's see what we can do with it and what could go wrong with it. So we are using ZX and application decompiler to reverse engineer the APK. So we can run a command ZX and smart Wi-Fi.apk. Sometimes it gives error, so you can ignore it. It will create a directory called smart Wi-Fi. We can simply go to the directory and look for the files, look for the juicy information in it. This file, Android manifest.xml, contains the permissions, intent, broadcast receiver information. So the permissions you agreed on while installing the app, like the permission for camera, storage, access, and any other permission, they lies in here. You can simply reverse engineer any APK and you can look out for those permissions in it. But we'll go to this directory, Hangzhou, ZX, and we'll look for this file. We'll open this file using nano. Now in this file, you can see some of the URLs are loading with HTTP. They are not even encrypted HTTPS. But if you look closely at this URL, this file has a path. This file has an extension of .bin, which we discussed. The firmware has extension of .bin or .binary. We'll download this firmware. So the firmware name is kkips.bin. Extract the content using binwalk. Go to the binary files and see what all binaries it contains. So if you look closely, there are 4 binaries which caught my eye, which is kkips off, which is used to switch off the plug, switch on the plug, to seek the Wi-Fi credentials. Now what we can do is we can simply emulate them and try attaching them with the debugger and to set our breakpoints to try to control the execution of the flow and to look for the vulnerabilities like buffer overflow. So now we have covered almost 3 layers. Let's move to the hardware exploitation part. We are not covering any demo for hardware and software defined radio. We are just because of the time crunch, but we will be covering them in our upcoming series of webinar on IoT security. So let's quickly discuss about the hardware exploitation part. In hardware interface exploitation, we will simply follow the approach of web application pen testing. We'll start with the recon phase and try to first open the device and look for the components like chips, RAMs, interfaces available, whether device is using serial or parallel interfaces. What is the difference between serial and parallel interfaces? Serial if consists of less pins but slow data exchange, but parallel has more pins with fast data exchange rate. Their common types of serial interfaces are UART, I2C, SPI. Some of them are asynchronous and some of them are synchronous. But after getting the interfaces, what would one can do with those interfaces and what is required to access those interfaces? So these are some of the tools or the hacking toolkit that you require to access or to sniff the debugs and boot up messages, logs messages, obtain shell access. So these are some of the tools, which is Edify Badge, Bus Pirate, Shikra. So on the each interface, what one can do? So for serial interfaces, you can sniff and debug and boot up messages, sniff logs, files, shells for the information in plain text or whether in an encrypted form. Then you can try decrypting them. Then the second interface is I2C and SPI interfaces. You can do EEPROM data sniffing and injection, memory dumping, debug output, and device management. Then for the last JTAG interface, which is a parallel interface, we can perform firmware dumping, firmware upgrades, testing, and debugging the device. But this firmware dumping is different from the router firmware dumping. But we will discuss them in more detail in our upcoming series of webinar. Then let's move to the last layer, which is software defined radio or IoT communication protocol. So these are the most common IoT communication protocols: Zigbee, LoRa, Sigfox, 4G, Wi-Fi, BLE. BLE is mostly used in smart wear devices like smart bands, smart watches. We can use to intercept the traffic, manipulate the traffic using tools such as Crackle. For this layer, we also require hacking toolkit devices like HackRF, RTL SDR, Blade RF, USRP, Matchstick. And to emulate the traffic, we can use tools like SDR software devices, GNU Radio, Crossmos SDR, Linrad, and SDR. And we will cover the demos of each one of them in our upcoming series of webinar. So I'll let Akshay to discuss the various best practices and the guidance for manufacturers, vendors, and developers, and for the consumers. So thank you. Over to you, Akshay.
Thanks, Mohit. What we just saw is a mere snapshot or a representation of the vulnerable IoT attack surface that is out there. And this was just to give you a brief understanding of the real security posture of the smart devices that we use day in, day out. But I'd like to believe if exists a problem, there also exists a solution, which actually brings us to the last leg of this webinar, where I will be talking about certain IoT security best practices. We need to understand that securing an IoT infrastructure requires a rigorous security in-depth strategy. This strategy requires you to secure data in the cloud, protect data integrity while in transit over the public internet, and securely provision devices. Each layer builds greater security assurance in the overall infrastructure. While building these devices, we must protect and secure the network connecting IoT devices to the backend systems on the internet by implementing traditional endpoint security features such as antiviruses, anti-malwares, firewalls, and intrusion prevention and detection system. Always allow the users to authenticate the IoT devices by introducing multiple user management features for a single IoT device. We must also not forget to encrypt the data at rest and in transit between IoT devices and backend systems by using standard cryptographic algorithms and fully encrypted key lifecycle management processes. Use IoT API security methods not only to protect the integrity of the data movement between IoT devices, backend systems, and apps using documented REST-based APIs, but also to ensure that only authorized devices, developers, and apps are communicating with APIs or detecting potential threats and attacks against specific APIs. We must place a robust testing framework in to ensure the security of IoT hardware. Also, given the lack of maturity in current IoT technology, the developers of the IoT apps must emphasize on the security aspect of their IoT apps by strictly implementing all of the above mentioned IoT security technologies. And we must also avoid launching IoT devices in a rush. An in-depth security strategy can be developed and executed with active participation of various players involved with the manufacturing, development, and deployment of IoT devices and infrastructure. IoT hardware manufacturers, or the integrators as they are famously called, the IoT solution developers, the IoT solution deployer, and lastly, the IoT solution operators. They all must follow security by design, or as I would like to call it, security at heart principle. To ensure the security of the IoT devices and applications, the device makers and app developers must be aware of the latest IoT security threats and breaches. We need to understand that IoT is no longer an emerging technology and breaches are bound to happen. Hence, all these players must be ready to face these breaches with a proper exit plan to secure maximum data breach with a proper in case of an attack or data. Everything is becoming a computer, so everything is vulnerable. IoT promises to change our future, but at the same time, it poses severe security risks. Therefore, we should stay aware and learn how to protect our devices against cyber attacks. And we must not forget that security is everyone's responsibility and it is the only discipline. Thank you.
Wow, that was an insightful session indeed. And the number of questions that I have received, it says it all. Due to the limitation of time, we would only be able to take 2 questions at this moment. So the first question that we have is, how will the Internet of Things impact the sustainability of the business, and will it have any impact on the environment?
Well, it's a great question, Vasundhara. Well, with the help of Internet of Things, you can definitely have a positive impact on the existing processes and the execution. For example, with the help of IoT, the street light systems can be managed way better than what we are going through now. Using an automation process, the street lighting system can be better managed and a lot of electricity can be saved and a lot of power could be used elsewhere where it is really needed. Also, I feel with the effective management, the amount of carbon emissions could also be reduced to drastic level because the street light system is effectively and efficiently managed. So I hope that answers the question.
Yes, definitely. Akshay and Mohit, as you might be working with multiple clients, how are you assisting them in their security testing requirements and getting them ready for 2020?
I'm glad this question came up, Vasundhara. So for this question, I'd like to take you back to, so here's a snapshot of our specialized practices at Q Infotech. So our security professionals are trained in, as you can see, they possess these many certifications, and we have to offer both the defensive side of the job and also the offensive side. So we have certified professionals, with certifications like CEH to something as big and as de facto as offensive security certified professionals. And also IoT penetration testing is one of the specialized practices at Q Infotech, but we also cater to vendors coming in with requirements of web, Android, network, thick client penetration testing, and cloud red team assessments, as you said in the beginning.
All right. So before we wind up, next month on 12th of December, same time, we have another webinar on blockchain testing, how to create trust and test its effectiveness via in-house SMEs. I hope you would all also join that and spread the word around. Details of the webinars in the next month and the video recording and a survey would be sent to you all within 24 hours from now. In case you have any further assistance, please feel free to write to us at info@qainfotech.com. Thank you once again, everyone. We sincerely appreciate you being here and wish you the very best in your journey of getting IoT security ready for 2020. Thank you so much.